Hello, my name is Grace McKenney, and today I would like to present my ongoing research titled Late Holocene Fire History Reconstruction from Beaver Lake in the northwest lowlands of the Olympic Peninsula, Washington. This research is part of my thesis project for the Cultural and Environmental Resource Management Master's Program here at CWU. The purpose of this research is to reconstruct the late Holocene fire history record of the Beaver Lake watershed using macroscopic charcoal analysis of a 3,400-year-old lake sediment core. This record will be interpreted within the context of what is known about past vegetation, climate, and human land use change through time in order to explain any observed shifts in fire activity during the late Holocene. This study includes the following 4 objectives. 1 is to reconstruct the late Holocene fire history of the Beaver Lake watershed using macroscopic charcoal analysis of a lake sediment core. 2 is to compare the Beaver Lake fire history record with the Beaver Lake pollen record created by Dr. Megan Walsh. 3 is to evaluate the Beaver Lake fire history record within the context of existing records of fire history, vegetation change, climate variability, and human land use activities from the Olympic Peninsula during the late Holocene. And 4 is to provide data from the Beaver Lake paleoenvironmental record to land managers in support of their efforts to manage fire on the landscape. The topographic map here shows the Olympic Peninsula with the location of Beaver Lake circled and the locations of other lakes that have had their fire histories reconstructed. This table here shows those previously studied lakes and their varying levels of fire activity. The darker color indicates an increase in fire activity, and the lighter colors show a decrease. This also shows the 4-letter alpha codes of the predominant vegetation, as well as how the climate has changed from wetter to drier, back to cold and wetter, and now warming since the last glacial maximum, or the last ice age. I would also like to highlight that people have been living on the peninsula for that whole time, and saw an increase in population about 4,000 years ago. Beaver Lake is a freshwater lake found about 170 meters in elevation in Clallam County, 6 kilometers northwest of the nearest town of Sappho, Washington. It is approximately 9.5 meters deep and is found on U.S. Forest Service land just outside of the boundaries of Olympic National Park. The inset photos taken by Dr. Walsh show some of the surrounding vegetation and the lakeshore. The fieldwork portion of this research project was completed during summer 2021 with the retrieval of a 6.21 meter long sediment core with a Livingston piston core. The photos here show our sampling platform on the left, a Livingston piston core in the middle, and a section of the sediment core on the right. There are 6 simultaneous parts to the lab work being conducted on the sediment core. First, magnetic susceptibility is measured at contiguous 1 centimeter intervals along the core using a Sapphire Instruments magnetic coil. This determines the amount of ferromagnetic material in the core, which can indicate the presence of things like tephra and erosional or landslide deposits. The preliminary results can be seen in this graph here. This shows the magnetic susceptibility changing as we go down the full core and thus back in time. Radiocarbon dating is still being conducted, so we do not yet know the ages at which these changes are occurring, but we hope to know soon. Second, the entire sediment core is being described with a Munsell soil chart. A majority of the core thus far has black or very dark gray gycha, or lake sediment. This can be seen in this photo of a 1 meter section here. Third, charcoal is analyzed through 2 cubic centimeter samples taken every 0.5 centimeters from the core. These samples are wet sieved through a nested 125 micrometer and 250 micrometer mesh. The remaining material is then quantified under 10 to 40 times magnification, with the charcoal being counted as either woody, seen here in photo A, which comes from trees and other woody vegetation, or as herbaceous, seen in photo B, which comes from shrubs, grasses, and other non-woody vegetation. The preliminary results of this analysis can be seen in this graph here, with the woody charcoal seen in black and the herbaceous charcoal seen in green. This graph only shows the first 1.5 meters of the core, but as you can see, there is an increase at about 0.5 meters. We cannot say for certain if this indicates a significant increase in fire activity or what would have started the potential fire. This will be determined by continued research. Fourth, loss on ignition is the loss of material from a sample after being heated. 1 cubic centimeter samples are taken every 5 centimeters, which are then heated to varying degrees to remove all excess moisture, then any organic and carbonate material. This helps determine how productive a lake is over time. The preliminary results of this analysis can be seen in this middle graph, which shows a consistent amount of carbonate material and a changing percentage of organic material through the top 4 meters of the core. Again, continued research will show the significance of these changes. Fifth, pollen is used to indicate any shifts in vegetation over time. 1 cubic centimeter samples are taken every 10 centimeters and will be analyzed by Dr. Walsh as we continue this project. Sixth, macrofossils are any organic material that could possibly be identified or used for radiocarbon dating, such as leaves, twigs, and conifer needles. These photos here show a leaf and conifer needle that were found within the first meter of the core. Currently, the sampling of this sediment core is almost complete. Continuing this research will entail completing both the sampling and then the lab work portion with the counting of charcoal and loss on ignition analysis. After this lab work will come the analysis part through which the shifts in fire activity indicated from the charcoal will be compared to multiple other records of landscape change. This figure here helps illustrate how the understanding of the local Beaver Lake fire history record will be enhanced through the additions of records of vegetation, climate, regional fire, and human land use activities, which will provide a more complete understanding of the paleo-environmental history of the Olympic Peninsula. I would like to acknowledge and thank my thesis committee of Drs. Megan Walsh, Stephen Hackenberger, and Craig Rebels, as well as the many people that helped retrieve the sediment core from Beaver Lake and helped complete the lab work, including Megan Klein, Ruth Rachel Fensky, Vanessa Highsmith, and Trey Winchester. Thank you for listening to my presentation, and I hope you have a good day.